Cambridge AS Computer Science, Chapter 12, Software Development, Part 2, Types of Errors. When you create a program, you need to do extensive testing because probably there would be some flaws or errors in your code. It's impossible to write the perfect code from the very first time unless it is something you have studied very well. But if you are inventing a new program, one of the stages of developing a program is the testing stage. Okay, so when you test, you have to find errors and fix them. Okay, so now we have a small talk about types of errors. A program fault is something that makes the program do not do what it's supposed to do under certain circumstances. Okay, we have syntax error in the first place. A syntax error is very simple error. It's just maybe a typo, a mistyping. So you typed a command incorrectly. Maybe this is the easiest error to find because the compiler or interpreter will say line number so is unrecognizable. It has a syntax error. So with little experience, you look and then you discover your error and fix. Okay, syntax error is an error in which a program statement does not follow the rules of the language. Maybe you are missing a bracket, you are writing if without end if. That kind of a construct or a statement in the source code that breaks the rule of the language. Syntax error is a misspelled word or brackets do not match. Okay, if the program does not contain any syntax error, then the program obey the rule and the grammar of the language. The program will run and it will be compiled or interpreted. Okay, so you have to see because these questions they come in exams and they are easy marks. Okay, another type of error is called logical error, and maybe this is more difficult to discover because your code following the rules of the language. However, is doing something not as you intend. For example, let me give you an example. For example, net profit is income plus expenditure. It should be minus. So this is a kind of a logical error. And sometimes, for example, if mark smaller, this is the error, smaller than 50, then print pass, else print fail. It should be greater than or equal 50. Okay, so this kind of logical error need more careful testing using dry run and trace table if it is manual, or you have some tools in the compiler. We call it integrated development environment. So you can set a watch window, you can set a breakpoint, or you can step through the program instruction by instruction and test values of variables so that you may discover that logical error. So logical error is an error in the logic of the solution that causes it not to behave as intended. It's an error in an algorithm or design. The program does not behave as expected, and it gives the expected out. The program wrong mathematical operation or wrong loop condition or something. Okay. A third type of error is called runtime error. It's an error that occurs during running. Maybe, for example, let me give you an example. The code is dividing two numbers. And while running, maybe for some reason, so it is A divide B, and for some reason, the B became 0. So any number divide 0 mathematically is impossible. So this is a runtime error. Maybe it is because of input. Okay, or maybe you are writing to a file and that file with that file name does not exist, or reading from a file, or maybe the flash memory or the memory stick is disconnected. Okay, so these are kinds of runtime error. Runtime error is an error that causes program execution to crash or freeze. A program performs an invalid operation, for example, tries to divide by 0. The program performs an illegal instruction or invalid divide by 0. See, things are repeated. Things are repeated. You know why? Because I copy them from mark scheme or endless loop or simply crash or freeze. Okay? So things they repeat because I just copy from mark scheme. These things are quite over. Okay, another question that asks ways to minimize the risk of fault when writing programs. How would you minimize the possibility of having errors? Okay, you may use tried and tested library routines. We studied that in paper 1. There are library routines, you just use them and they are tried and tested and error-free. Use modular programming. Divide your program into modules and test and program each module separately and test each module separately. This makes you deal with smaller tasks so you can better manage. Okay, good programming practice like formatting. Use sensible variable names. Okay, put comments. All these of things help you to write a code with less errors. Use the ID feature, for example, type checking and autocomplete. IDE is the integrated development environment. It has so many features that help you with write correct code. Okay, so that was about errors and how to minimize errors. Okay, then testing strategies. Then we go to another stage that is testing. So you have test data. You should be familiar with normal test data, abnormal test data, extreme test data. There is also what is called the stop testing. Let us study it. Integration testing, white box testing, black box testing, all of these, alpha testing, beta testing, acceptance testing, all of these, when they come in the exam, you say, okay, these are the easy marks I should gain. Easy marks, okay? Finding syntax error is easy. So testing strategy, finding syntax errors is easy. The compiler or interpreter will find them for you and which usually give you a hint as to what was wrong. Okay? Much more difficult to find are logical errors because the program will run and will sometimes will output correct results, sometimes will under certain circumstances it will output incorrect. So you have to test every route inside of your code. This is called white box testing, and this should be done by someone who knows the code. So white box testing is going through every if and else and then condition. And this should be done by someone who knows the code. There is also another kind of testing that is called black box testing. Black box testing is done by someone who doesn't know the code. He only knows what input and what should be the expected output. He's only thinking of this. This will help some way and the other will help other way. So you have white box testing done by someone who knows the code, is done by black box testing, someone who doesn't know the code. There is also what is called the stop testing. We will go through it. For example, you create a program with modules. When you call a module, it should work. However, if you want to test the program before creating the module, you put a stop inside that module that just says, yes, I am running or so, to make sure your code is just calling modules correctly. Integration testing, when you do a program with several modules, okay, you test each module separately and you test the efficiency of all of them together or the correctness of all of them together. We call this integration testing. Okay, alpha testing is testing in-house. Alpha testing is done inside the company by employees inside the company. Beta testing is done by some prospective customers or selected customers. Okay, so you need to know all of these, they come as definitions. or ask you about your knowledge about them. Yeah, very easy marks. Just know them all. And I have collected everything that has appeared in the exam. I didn't leave anything. Okay? Acceptance testing. When you, for example, you have a customer and you did everything for him, and you would like him to do the final testing and sign that he has accepted the program and pays everything. This is called acceptance testing. Okay, let's go through them bit by bit, and let us study them in detail. Okay, so you have test data. You should be familiar with that. You have normal test data. Normal test data is data, acceptable data that should be within the range. Okay, especially if you do validation. So normal test, for example, if your validation rule is to accept values from 0 to 100. So normal test data would be 70, 80, 90. You should be familiar with this because we did validation. Okay? Abnormal test data, sometimes called erroneous, which has errors. Okay? So abnormal test data, for example, if it is 105, this is outside of range. Or maybe 50, but written in text. This is of the wrong data type. And you have boundary. We call it extreme. Okay, boundary on the limit. We have two values for the boundary. Boundary accept and boundary reject. Boundary accept is extreme. 100 is boundary accept. And this is extreme. Boundary reject is 101. Is the first value in the reject range. Okay? Okay, you should be familiar with all of these. Okay? And okay, so you know now normal valid test data, abnormal erroneous test data, and boundary extreme test data. Okay? Let us say more about stub testing. So stub, you put a stub instead of the module. You haven't created the module yet. However, you would like to test that the main program is calling that subprogram correctly. So instead of the code of the subprogram, you write print, for example, just one sentence, we call it the stub. Just print, hello, this module has been called successfully. Okay? So stub testing may be carried out before the modules are developed and not ready for full testing. Module stubs contain simple code to provide a non-response to output a message to confirm the module has been called. Okay? Okay, I'm giving you an overview, and you should go and study and read my notes bit by bit and memorize. Okay? Okay. What about integration testing? You create modules, you test modules individually, and then you test the integration of these modules together. So integration testing is individually tested modules are joined into one program and then tested to ensure the modules interact correctly. White box testing. I said white box testing is testing every root inside the code. And this should be done by someone who has written that code, or he has thorough knowledge of the structure of the code, because it is like a white box. And a white box is a box that you can see what's inside. So this is a white box. Okay? So white box testing every path through the program code. What is black box? You are blind. You cannot see what's inside the box. However, you have a list of specification. What input should produce what output? And you just input, output. You compare out exact result, program result with expected result. Okay, so black boxing is just make sure the code satisfies the specification. Okay, and then, okay, look at these examples. They are just examples from exam. The student does not need to know the structure of the code. This is black box. The student chooses data to test every possible path through the code. This is white box. The student chooses normal, boundary, and erroneous data. This is both with white box and black box. Okay, so that's why I wrote here normal, abnormal test data outside black box and white box. Okay, with both. The student choose data to test the program meets the specification. Just meets the specification, so this is black box. Okay, these are all definitions. Okay, alpha testing. Testing is testing the software in-house, inside the company that has created that software. Okay, beta testing is testing the software by a limited number of chosen users before general release. Acceptance testing, testing of software by customers before signing off. They sign, pay everything, take their product, and go away. Example, you may choose more than one. Software is tested in-house by dedicated testers. Someone may work in a company just for the purpose of testing software. It would be a lot of fun if the company is creating games. You just play games and earn money and report flaws or bugs or errors. Okay, software is tested in-house by dedicated testers. This is integration testing. This is alpha testing. And if you say beta testing, it will be accepted. But I wouldn't choose this. What's in bracket is optional. If you put it or do not put it, this will not affect your mark. And this is the mark scheme. Okay, software is tested by clients before it is signed off. This is acceptance testing. Software is testing by combining modules that have previously been tested to check they work as expected. This is integration testing. Software is tested using normal, abnormal, and boundary. This is everywhere. Integration, acceptance, alpha, and beta, everywhere. Okay, software is tested by releasing it to selected customer who test it in normal circumstances. This is beta testing. Okay, shabab. What else? Program testing using IDE. IDE is an integrated development environment. Okay, it allows you to write the code. It allows you to compile and run the code. It also checks the syntax for you. Okay, however, if you have a logical error in your program, you may like to set breakpoints. The code runs until the set breakpoint and it stops. Then you investigate and examine value of variables, try to figure out what is making it behave incorrectly. Okay, you may put a variable watch. You put watch on a variable that its value is not normally printed. You put a watch on it or a report window to see the value of this variable while being calculated. Or stepping, you may wish to run the program step by step, instruction by instruction. So these are the debugging tools in your IDE, integrated development environment. Maybe they expect that you are doing some practical work, even though you will examine in pseudocode only. But they will expect that you are using PyCharm or Python. So you have an idea what is this. Okay? So these are examples. Okay, a point where the program can be halted to see if the program works to this point. This is name of the debugging feature. A bug is an error in program. A bug is an insect. However, for some reason, some funny story, in old days, computers used to be machines. Okay, and once a computer was not performing because one bug was inside the machine or between gears. And when the engineer or technician removed that bug, it worked normally. So from now on, debugging is finding and fixing errors in a program. Okay, so debugging feature, these are the debugging feature. Debugging is the action of finding and correcting errors, bugs in a program. And IDE often contain features to help you with debugging. Okay, be familiar with those because they show in exams. Okay, so this is called a breakpoint. One statement is executed and then the program waits for input from the programmer to move to the next. This is called the stepping or stepping through or stepping over or stepping into. These are technical terms inside the IDE itself. Step through, step over, step into. You don't have to know differences between them. This is just stepping. Okay, this is just another question about connect. Okay, so the IDE feature and the description. Context sensitive prompt. They are giving you hints that depends on what you are writing. Okay, this displays predictions of the code being entered. It's predicting. What do you mean? And auto-completing. Okay, dynamic syntax check. Underline or highlight statements that do not meet the rules of the language. Breakpoint stops the code executing at a set line. Single stepping executes one line of the program and then stops. Report window output the contents of variables and data structures. I would like you to study these sentences. This is the language of the exam itself. Try running an algorithm. When it's an algorithm, then it's pseudocode. And when you dry means you run it by hand. Okay, a good way of checking that an algorithm works as intended is to dry run the algorithm using a trace table and different test data. You are quite familiar with this because it shows in the programming. You are given a pseudocode, you are giving a flowchart, and you are asked to dry run. Dry run is the process. A trace table, because you have variables and you'd like to know values, intermediate values of variables. Values are stored in memory. However, when you dry run, you put the values in the table. So you need that trace table. A trace table is a table with a column for each variable that record their changing values. The idea is to write down the current contents of all values and conditional values at each step of the algorithm. Okay. Another thing, testing with walkthrough. A program is checking by creating. Yeah, just know that walkthrough is an alternative to dry run. Okay. By creating a trace table and going through the program line by line and record and check variable values as they change. An error may be indicated when the variable given an unexpected value. An error may be indicated by an unexpected pass through the program. Faults in the program and can be detected. This is called testing using walkthrough method. So the walkthrough method is just dry running the algorithm. Just it showed in the exam with that name, walkthrough, and I would like you to know the last word to say in that chapter. And this is the end of my notes. Okay, the last thing is that you may do maintenance. When you sell the software and give it to a customer, maybe afterwards you need to maintain. There are 3 types of maintenance. One of them is called corrective maintenance, and then the second, adaptive maintenance, and the last is perfective maintenance. And you need to know them all. What is corrective maintenance? Correct means an error is now discovered. And a hidden error is now discovered. And you need to correct it. So corrective maintenance, the programmer is to be blamed for that because he issued the software with some hidden errors. Okay, so this is called corrective maintenance. It's okay. However, adaptive maintenance, the programmer is not to be blamed. Why? Because adaptive maintenance is about adapting to new requirements from the client. Yeah, it's okay. The client is asking more features, so I can adapt my code to accommodate his new requirements. So the programmer is not to be blamed now. Adaptive maintenance, yeah, new requirements. What about perfective maintenance? Also, the programmer is not to be blamed. The code is working, but for some reason you'd like to, that's why they issue updates. For some reason you'd like to enhance the speed, enhance the performance, some new technology. No, new technology appeared is for adaptive maintenance. Okay? Perfective maintenance, just improve the efficiency. You need to study them very well. I will go through and read every sentence. Okay? Corrective maintenance is correcting identified errors. Corrective maintenance of a program refer to the work required when a program is not working correctly due to a logical error or runtime error. Okay? Sometimes errors do not appear in the acceptance testing and alpha testing and beta testing. They appear later on when customers are using the software. So you must do corrective maintenance. Okay, adaptive maintenance is amending a program to enhance functionality or in response to specification changes. The customer changed his mind. He wants some new features. Okay, okay. Once in the exam, there was a question that said, give reasons why you would need to do adaptive maintenance for a website. You have to invent some reasons. Change to the website requirements. Okay, we know it. Change in requirements will result in adaptive maintenance. What else? New technologies, a new browser, a new host, change made to the library routines. So you need to do adaptive maintenance. Change in legislations. For example, now in Europe, any website that is using cookies must output a message asking the user whether or not he accepts using cookies. So this is change in relevant legislations. The last thing is perfective maintenance, is modifying a program to improve performance or maintainability. The program runs satisfactorily. However, there is still room for improvement. Okay, that's the end of the chapter. That is the end of the notes. Hopefully, it's a nice end for the syllabus. Thank you very much for listening.